गुड इवनिंग एवरीवन। सभी को नमस्कार। सभी का एक बार फिर से स्वागत है इस प्लेटफॉर्म पर जिसका नाम है वन मार्क सोल्यूशन। और जैसा कि आपको पता है कि लगातार वन मार्क के इस प्लेटफॉर्म से हम डिफरेंट सब्जेक्ट के डिफरेंट चैप्टर्स के वन मार्क के क्वेश्चंस को डिस्कस करते आ रहे हैं। कंटिन्यूअसली वी आर कंडक्टिंग वेबिनार्स फॉर द वन मार्क क्वेश्चंस फ्रॉम द डिफरेंट चैप्टर्स ऑफ द डिफरेंट सब्जेक्ट्स विद द डिफरेंट subject experts. And today we are going to discuss about the today's webinar is based on the vectors is the topic for the physics. It is generally whatever I know that is useful for class 11th as well as for the class 12th. So today we are going to discuss about the vectors and to discuss vectors we have the resource person Mr. Hitesh Parmar sir, Hiten Parmar sir. Hiten sir, आपका बहुत बहुत स्वागत है इस प्लेटफॉर्म पर। और
Thank you, sir.
हमारे
Good
जो
evening.
व्यूअर्स हैं they know that Hiten sir have already taken so many webinars on this platform. Hiten sir is working as a PGT physics in my own school Jaipur and also running his own institute with the name Physics by Hiten Parmar. So he's a very knowledgeable person in the field of physics, have a very long experience, also associated with the different training programs by the CBSC and CBSC के जो कंटेंट वगैरह प्रिपरेशन होता है उसकी भी टीम में सर काम करते हैं। साथ में जो भी प्रिपरेशन होता है, जो भी चेंजेस आते हैं उसके रिलेटेड जो भी नया कंटेंट अवेलेबल होता है, सर के खुद के बनाए हुए बहुत सारे कंटेंट अवेलेबल हैं जिनको कि आप सर के साथ कांटेक्ट करके भी पा सकते हैं। सो मैं ज़्यादा समय नहीं लेते हुए मैं सीधे अपने जो हमारे व्यूवर्स हैं जो पहली बार इस प्लेटफॉर्म पर आए हैं, जो पहली बार इस प्लेटफॉर्म को ज्वाइन कर रहे हैं, दे कैन सब्सक्राइब द चैनल फॉर द अपकमिंग वेबिनार्स। और जो पिछले वेबिनार्स हम कंडक्ट कर चुके हैं उन वेबिनार्स की वीडियोस को एक्सेस करने के लिए भी वो इस चैनल की दे कैन विजिट द प्लेलिस्ट ऑफ दिस चैनल, प्लेलिस्ट फिजिक्स 11th एंड फिजिक्स 12th. So I would not take much time. I would like to hand over Hiten Parmar sir. Hiten sir, please continue.
Good afternoon, everyone. As you all know that if we talk about vectors, in vectors, the basics of physics are completely withheld in this particular topic. And when we say that we are talking about vectors, then we very well can understand that we are somewhere or the other discussing complete physics of class 11th and 12th. मतलब अगर वेक्टर्स आते हैं तो आप 11th 12th की फिजिक्स को बहुत इजीली एसेस कर सकते हैं, और अगर वेक्टर्स में कोई प्रॉब्लम है तो आपके लिए 50% ऑफ द सब्जेक्ट इज गॉन. टुडे आई एम गोइंग टू गिव यू सम बेसिक आइडिया ऑफ दिस पर्टिकुलर टॉपिक, वेक्टर्स. वेक्टर्स 11th एंड 12th दोनों में हम लोग इंक्लूड करते हैं, बट बेसिकली फिजिक्स में इन क्लास 11th vector is a very big part of chapter number 3. Then the two type of products of vectors are accumulated or they are adjusted with chapter number 6 and chapter number 7. Chapter number 3, chapter number 4, vector as a whole is there. Chapter number 6 and chapter number 7. 4 chapters have the basics of this particular topic, vectors, in various different forms or in fractions at various places. But along with it, it controls the complete first book and a part of second book of class 11th, complete first book and a very small part of second book of class 12th. For competitions, if we talk about, again, vector itself has a very good weightage and it controls or it withholds many other chapters, because without vectors you cannot carry out various phenomena or various calculations or various effects. We cannot study that without vectors. In this particular topic, I am going to stress a bit more on theory because this is the basic of the subject, and then we'll talk about the questions that are generally appearing from it. The first very important point, we talk about what vectors is. There is a big misconception related to what vectors is. Generally, when we talk about vectors, the first thing that comes into our frame of mind is a vector quantity, and we say that quantities are of two kinds, scalar quantities and vector quantities, and one that has magnitude as well as direction is known as a vector. But all quantities that have magnitude as well as directions, we cannot call them as vectors. There is a bit of confusion or a bit of dilemma over there. थोड़ा सा यहाँ पे कुछ मिसकंसेप्शन है. दैट इज वाई आप बोर्ड स्क्रीन पे देखें क्या लिखा हुआ है. फिजिकल क्वांटिटीज हैविंग मैग्नीट्यूड, direction, and that obeys all the laws of vector algebra are called vectors. If I talk of work, almost all of you might have done that topic till now in your schools or in your curriculums. Work is said to be a scalar quantity, but we talk about positive work, we talk about negative work. Current, call it a scalar quantity. We say that it is running clockwise, it is running anti-clockwise. Then it means somewhere that we are talking about magnitude as well as direction for work as well as current. But they both are scalar quantities. So if a physical quantity has magnitude and direction both, then it does not always imply that it is a vector. For it to be a vector, the third condition of obeying laws of vector algebra has to be satisfied completely. The most common thing that we talk about or that is being asked from vectors is a unit vector. Many questions appear from that. They have been there in the past in various exams, and it would keep on coming, it would keep on appearing. A vector divided by its magnitude is a unit vector. A vector comprises of magnitude as well as direction. If modulus of A is magnitude, if A cap is the direction, then this A cap is also read as unit vector. A unit vector for A is A cap, and it is the ratio of vector A with its magnitude. Zero vector, an arbitrary vector which cannot be drawn, but it can be always talked of. A vector having zero magnitude with any arbitrary direction is known as a zero vector. Vector addition is the biggest of the three important topics that we talk about with vectors. Addition, then two kind of products we discuss. First is vector addition. Three laws rule this particular part of vectors. Triangle law of vector addition. This is used when two consecutive vectors, one vector followed by the other, is being used. If two non-zero vectors are represented by two sides of a triangle taken in same order, that is the consecutive sides of a triangle, then the resultant is given by the closing side of triangle in opposite order, in opposite direction. In the given figure, OB is the resultant. Two vectors OA and AB are continuous vectors, and OB is their resultant vector by triangle law of vector addition. Next is parallelogram law of vector addition. This is used when two adjacent sides of a parallelogram can be represented by the two given vectors. The vectors have to be co-initial. They should be having same starting point or sometimes the same terminal point as well. If two non-zero vectors are represented by two adjacent sides of a parallelogram, then the resultant is given by the diagonal of the parallelogram passing through the point of intersection of the two vectors. The magnitude of the resultant vector, both for triangle law and parallelogram law, can be calculated by the formula of root over a square plus b square plus 2ab cos theta. The direction of the resultant vector with vector OA in the given figure is given by b sine theta upon a plus b cos theta. Under any circumstance, if you are being asked the direction of the resultant vector for vector OB with vector OB, then it would be a sine theta is equal to b plus a cos theta. A and b would get their positions interchanged. Next is polygon law of vector addition. When more than two vectors, consecutive vectors, if the number of zero vectors, non-zero vectors, are represented by the n minus 1 sides of an n-sided polygon, then the resultant is given by the closing side or the nth side of the polygon taken in opposite order. It means if 5 consecutive sides of a polygon represents the 5 given vectors to be added, then the 6th side in opposite direction would give you the resultant vector. Subtraction of vectors is actually not a concept. There is nothing like subtraction of vectors, but even though if we ever have to subtract two vectors, 3 plus 4 is 3 and 4 to be added. But 3 minus 4 can be written as 3 plus into minus 4. That is being used over here. Vector A minus vector B is equal to vector A plus negative of vector B. That means the direction of vector B reversed if added to vector A would provide you vector A minus vector B, and its modulus would be, the angle would be changed from theta to 180 minus theta in this case. Rest formula remains the same. Root of A square plus B square plus 2AB cos 180 minus theta. You can also further resolve it to get A square plus B square minus 2AB cos theta, but it would not be the correct way of writing it. One thing I would like to add over here, in a parallelogram, if the two sides represent the two vectors to be added and the diagonal gives you the resultant vector, the diagonal that we are talking about in this case, look at the figure, is the diagonal having the same starting point as the two vectors. OC is the resultant vector. OA and OB are the two vectors to be added. So the initial point of the diagonal and the two given vectors have to be the same for the diagonal to be the resultant. The other diagonal of the parallelogram, that is diagonal AB or BA, represents the difference of the two vectors. While carrying out calculations with vectors without these formulas that we talked about just now, the best way is to resolve the vector into two rectangular components, two perpendicular components. A vector R can be resolved into two perpendicular vectors of magnitude R cos theta and R sin theta, where theta is the angle between the vector R and the R cos theta component. Suppose vector R is to be resolved along x-axis and y-axis respectively, then the component along the x-axis would be R cos theta if it makes an angle theta with x-axis, and the other component in the direction of y-axis would be R sin theta, and vector R would be then equal to R cos theta I cap plus R sin theta j cap. I hope you all very well know that I cap, j cap and k cap are the unit vectors along the x-axis, y-axis and z-axis respectively. I can also say that I cap, j cap and k cap represent the direction of positive x-axis, positive y-axis and positive z-axis. If any vector R in 3D system is to be considered and it makes an angle of alpha with x-axis, angle of beta with y-axis, and angle of gamma with z-axis, then the direction cosines, that is cos alpha, cos beta and cos gamma, follow the shown relation cos square alpha plus cos square beta plus cos square gamma. It always has to be equal to 1. This is many a times used while solving questions related to vectors. When a point have coordinate x, y, z, then its position vector is given by xi cap plus yj cap plus zk cap. All the three coordinates x, y and z are attached to their respective directions I cap, j cap and k cap, and the complete vector equation or vector expression is framed. But if a particle moves from a given point to another point, suppose from a point x1, y1, z1 to a point x2, y2, z2, then its displacement vector is given by associating I cap, j cap and k cap with the differences of the respective coordinates of x, y and z. Suppose x1, y1, z1 is point A and x2, y2, z2 is point B, then vector AB is given by x2 minus x1, final point minus initial point, x2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. If it is vector BA, then the converse of it, the reverse of it would happen. Now, if it is BA, then A is the final point. So, final minus initial makes 1 minus 2. x1 minus x2, I cap, y1 minus y2, j cap, and z1 minus z2, k cap. Product of vectors and addition of vectors are the two mathematical operations that we generally talk about with vectors. Product of vectors are of two kinds, scalar product and vector product. Scalar product, also more commonly known as dot product, as it is represented by a dot between the two vectors, A dot B, it is how pronounced as, and the other the cross product or the vector product. It's known as cross product because it is A, then a symbol of cross, then vector B. It is represented by a symbol cross between vector A and vector B. That is why we call it a vector product. Scalar product, as the name depicts, give you a scalar resultant. Means the answer that you get by multiplying two vectors A and B for a dot product or a scalar product, that is A dot B, only represents the magnitude. The answer has magnitude only, the answer has no direction. Whereas when you talk about cross product or vector product, the resultant vector is having a direction. As the name itself is vector, it has a direction with it. We carry out scalar product when the two vectors to be multiplied are in the same direction, or when the product of a vector is to be carried out with the component of another vector in its direction. Work, force into displacement in direction of force. Then it would be a dot product or scalar product of force and displacement that will provide you work. Dot product A dot B is always equal to magnitude of A into magnitude of B into cosine of angle between A and B. Dot product A dot B is equal to A B cos theta. If we follow this particular concept that it is AB cos theta, we know that two vectors in the same direction would be having an angle 0 between them, and cos 0 is 1. So product of two unit vectors in the same direction always gets 1. I cap dot I cap, j cap dot j cap, k cap dot k cap, these all are equal to 1. If it is vector A dot A, then the resultant would be A square. It is magnitude of A into magnitude of A in that case. Scalar product or dot product of two vectors which are perpendicular to each other is always 0 because cos 90 leads to 0. So I dot j, j dot k dot I dot k dot j dot I, these all would be 0. In short concept, in tricky form, if we want to say, then scalar product of two vectors is to be calculated. Then the components of I cap, components of j cap, and components of k cap are multiplied along with each other and added. That means coefficient of I cap in one vector into coefficient of I cap into another vector plus coefficient of j cap in one vector into coefficient of j cap in another vector plus coefficient of k cap in one vector into coefficient of k cap in another vector. This would always provide you, suppose in the given expression on the screen is ax bx plus ay by plus az bz. The next vector, that is a vector product that gives you the resultant as a vector, is the product of two vectors mutually perpendicular to each other or product of a vector with the component of another vector in a direction perpendicular to the given vector. A cross B, as we call it or pronounce it, is always equal to magnitude of A into magnitude of B into sine theta, always associated with a unit vector. N cap represents any direction. It tells us that the resultant is a vector quantity. Its magnitude would be simply A B sine theta, where A and B are magnitudes of vector A and vector B, and theta is the angle between the two vectors. While measuring, while calculating, while determining the angle between two vectors, you should always keep this in your mind that the two vectors should be having common initial point. They should be co-initial vectors while calculating the angle. Vector product or cross product of two parallel vectors would always be 0 because it has the component sine theta in it, and sine of 0 is always 0. But whereas vector product of perpendicular vectors is always going to be something that we can calculate. The directions when multiplied to each other, two mutually perpendicular directions, x and y, cross product between x and y would always be along the z axis, between y and z axis would always be along x axis. If it is between z and x axis, it would always be along y axis. So I cross j is equal to k cap, j cross k is equal to I cap, and k cross I is equal to j cap. As you can see in the three expressions, k represents z axis, I and j represents x and y axis. Z axis is perpendicular to x as well as y axis. So the resultant of cross product is always perpendicular to the two vectors being multiplied. The resultant of cross product, the answer of cross product is always perpendicular to the two vectors being multiplied. In terms of components, if the vectors are ax I cap plus ay j cap plus az k cap and bx I cap plus by j cap plus bz k cap, then a cross b is given by this particular expression. It is solved. It is called the determinant of matrix method. And determinant of matrix method, this is how we solve it. Angle between two vectors, if ever needed to be calculated. Angle between two vectors, if ever needed to be calculated, is calculated by these two formulas. One is sine theta is magnitude of cross product of the two vectors upon their individual magnitudes. We get theta is equal to sine inverse magnitude of a cross b upon magnitude of a into magnitude of b. Similarly, from dot product formula, we can get theta is equal to cos inverse a dot b upon magnitude of a into magnitude of b. A very compulsory ingredient of vectors for calculation of equilibrium. For any triangle ABC with its three sides representing the three vectors or forces as A, B, and C vectors in the given figure. The bottom one is vector A, the left one is vector C, the right one is vector B, the sides of the triangle I am talking of. Lamy theorem says the ratio of sine of angle containing the side to the length of the side. In the figure you can see vector A has angle alpha opposite to it. So it is sine alpha upon A. Vector B has beta opposite to it. So it is sine beta by B and sine gamma by C. This ratio would always remain the same. This is Lamy theorem that is used to solve many questions in laws of motion chapter. Now coming to questions. Anytime if you have any sort of doubt in the things being taught, even after the class, the number is written on the screen. You can just note it down and put a WhatsApp with the question number marked or with the screenshot, or if any other doubt from the subject you have, you can always call on me on this number. You can basically, it's better that you WhatsApp your problem and I'll discuss it to you as and when I get time. It would not be more than 24 hours for sure. First question. A car travels 6 kilometers towards north at an angle of 45 degree to the east and then travels distance of 4 kilometers towards north at an angle of 135 degree to the east. How far is the point from the starting point? What angle does the straight line joining its initial and final position make? What angle does the displacement make with the east direction? The options are there in front of you. One of the method of solving this question is there on the screen. Net movement along x direction. Sx is 6 minus 4 cos 45 I cap. Sy is 6 plus 4 sine 45 j cap. But if you are not able to understand this particular logic, the same question can also be done by a bit different method. First displacement is 6 kilometer at an angle of 45 degree to the east. 6 kilometer towards north at an angle of 45 degree to the east. That means they are talking about southeast direction. Southeast direction. Think of it. What would be the vector represented by this particular motion? Can I write it as 6 cos 45 I cap plus 6 sine 45 j cap, northeast, first quadrant. So both I and j cap have to be positive. So x 6 by root 2 I cap plus 6 by root 2 j cap. Similarly, a vector can be framed for the second part of 4 kilometer as well, and you can add them to get your answer with more ease. But this is the theoretical method of representing it in the notebooks, and the answer here comes to be root 52 kilometer with tan theta as 5, or theta is tan inverse 5. There are two force vectors, one of 5 Newton and other of 12 Newton. At what angle the two vectors should be added to get the resultant vector of 17, 7 and 13 Newton? The three angles. The angle when it added gives you 17 Newton. When they are being added gives you 7 Newton. When they are being added, they give you 13 Newton. If two vectors are added in the same direction, their magnitudes are added 5 and 12. That gives you 17, 0 degree. If they are in opposite direction, their difference 12 minus 5 is 7. Gives you the next answer is 180, opposite vectors. What about the third? In this particular question, A is the answer because none of the other option is having 0 and 180, but 5, 12 and 13 are Pythagorean triplets. That means 5 square plus 12 square gives you 13 square. So if 5 and 12 Newton vectors are perpendicular to each other, then the resultant is the hypotenuse of the rectangle formed. The parallelogram formed over here is a rectangle, and by Pythagoras theorem you can get it to be 13 Newton. So option A is 0, 180 and 90. Given that vector A plus vector B is equal to vector C is 0. Out of three vectors, two are equal in magnitude and the third vector is root 2 times that of either of the two having equal magnitude. There's some misprint. given that vector A plus vector B is equal to vector C is equal to 0 is not there. Then the angles between vectors are given by, if A plus B is equal to C, then they represent the three sides of a triangle. And if they represent three sides of a triangle, the three vectors sum up to 0 from a closed polygon. Look at the figure. The angles are mentioned over there, and the angles when calculated would give you alpha as 90. It was root 2. So beta as 135 and gamma also as 135. And that is why option D is your answer. If vectors A is equal to 4i minus 3j and vector B is equal to 6i plus 8j, then magnitude and direction of A plus B. It's a very simple question. If you want to get the resultant magnitude, simply add I to I and j to j and then calculate the magnitude of the vector by under root a square plus b square plus c square concept. If I add the two vectors, I get the resultant as 10i plus 5j. Its modulus would be root of 10 square plus 5 square. That is 5 root 5. Whatever the unit of measurement is. Direction in vector 10i plus 5j is always given by the coefficient of j cap upon coefficient of I cap is equal to 10 theta. So here it is 1 by 2, 5j upon 10i, 5 by 10. It is 1 by 2 and the angle would be tan inverse 1 by 2. A truck traveling due north at 20 meter per second turns west and travels at the same speed. Traveling to north, 20 I cap, turns west. So traveling to north is 20 J cap, turns west. It is minus 20 I cap. Change in velocity, final minus initial. The resultant that you'll get is 20 root 2 and the direction would be 45 degrees south of west. If the sum of two unit vectors is a unit vector, then the magnitude of their difference is. The options are root 2, root 3, 1 by root 2 and root 5. If n1 and n2 are the two provided unit vectors, then the sum is ns is equal to n1 plus n2 both in n cap conditions. By applying the vector sum formula, we get under root a square plus b square plus 2ab cos theta. So here it would be under root n1 square plus n2 square plus 2n1 n2 cos theta. So ns square of the magnitude would be root is removed n1 square plus n2 square plus 2 n1 n2 cos theta. Here n1 and n2 and ns, all the three represent 1. They are unit vectors. So 1 is equal to 1 plus 2 into 1 cos theta. So 1 is equal to 1 plus 2 cos theta, and theta comes to be minus half. So theta is equal to 120 degree. Cos theta is minus half. So theta is 120 degree. Now if we talk of difference of the two vectors, how can we get the difference of two vectors? The difference is n1 cap minus n2 cap. I told you that subtraction of vectors, the resultant comes to be a square plus b square minus 2ab cos theta. So it would be n1 square plus n2 square minus 2 n1 n2 cos theta. And when we substitute the values of n1, n2 and theta, we have theta already over here. We get the resultant as root 3. So option B is the correct answer. Sum of magnitude of two forces acting at a point is 18 and magnitude of their resultant is 12. If the resultant is at 90 degree with the smaller force, what is the magnitude of the two forces? Let P is the smaller force and Q is the greater force. P plus Q is 18. So we can get P is equal to 18 minus Q, or Q is equal to 18 minus P, and substituted it in the formula for the resultant. R is equal to root P square plus Q square plus 2PQ cos theta. And angle is given by Q sin theta upon P plus Q sin cos theta over here. Now for this, the compulsory condition, what can it be? 10 of the resultant direction is given by Q sin theta upon P plus Q cos theta. So tan phi has to be equal to tan 90, that is infinity, that is 1 by 0. So I can say that P plus Q cos theta is equal to 0. And from here, you can very easily get the answer to be option C. Two forces F1 is equal to 1 Newton and F2 is equal to 2 Newton act along the lines x is equal to 0 and y is equal to 0 respectively. Then the resultant of forces would be line x is equal to 0, that represents y-axis, that represents j cap. So vector F1 would be j cap. Similarly, vector F2, y is equal to 0 is x-axis, I cap. So it is 2 I cap. Resultant of the forces. Simply add them to get the resultant. The resultant is answer D, 3I plus 2j. But three vectors A, B, and C as 2I cap plus j cap, 3j cap minus k cap, and 6I cap minus 2k cap. The value of A minus 2B plus 3C. 2B means vector B to be multiplied by 2. 3C means vector C to be multiplied by 3 as a whole. The solution is there in front of you on the screen. 2B plus 3C. A minus 2B plus 3C. A is written as such 2I plus j minus 2 into 3j minus k plus 3 into 6I minus 2k. Add the I, j and k parts to get the resultant as option B, 20I minus 5j minus 4k. A vector A is turned without a change in its length through a small angle d theta. Magnitude of A remains the same, only its direction is changing. And if direction is changing, then what can be done? The value of mod of delta A and delta A. Delta A is 0. The two vectors A at two different positions, when they are rotating, are having the same length. So there is no change in length, but change in direction is there. So delta A magnitude can be calculated. This is the solution of it. Magnitude of change in vector A is equal to A d theta. Because while talking of the change, vectors are to be considered. A d theta comma 0 is your answer. You can try this question. An object of m kg with speed of v meter per second strikes a wall at an angle theta and rebounds at the same speed and same angle. The magnitude of the change in momentum of the object will be. The two vectors with velocity v1 and v2 would have the momentum as p1 and p2 in the directions shown. P1 can be resolved into two parts, mv sine theta I cap minus mv cos theta j cap. P2 is mv sine theta I cap plus mv cos theta j cap. There is P1 is a bit wrong. It is minus mv sine theta I cap plus mv cos theta j cap. So change in momentum is P2 minus P1, and you can get your answer. The magnitude would be 2mv cos theta, and they are along some particular direction, and that direction over here is j cap. A particle moves 5 meter in positive x-axis direction. What would be the displacement of the particle? As simple as that. Positive x-axis direction, that is I cap. So the answer is 5 I cap. Position of a particle in the rectangular coordinate system is 3, 2, 5. What would be its position vector? I told you that it is 3 I cap plus 2 j cap plus 5 k cap. B is the correct answer. The particle moves from point P having the coordinate 2, 3, 5 to point Q having coordinate 3, 4, 5, then the displacement vector would be point P to point Q. That means P is the initial point, Q is the final point. 3 minus 2, that is 1 I cap. 4 minus 3, that is 1 j cap. And 5 minus 5, that is no k cap is there. So option C, it is the correct answer. A force of 5 Newton acts on a particle along a direction making an angle of 60 degree with vertical. A force of 5 Newton acts on a particle along a direction making an angle of 60 degree with the vertical. Its vertical component will be, if it is 60 degree with vertical, then the vertical component would be F cos 60, that is 5 into cos 60 is half, that is 2.5 Newton. Option D is written in reverse, it is 2.5 Newton over there, it's not 5.2. If A is equal to 3 I cap plus 4 j cap and B is equal to 7 I cap plus 24 j cap, the vector having the same magnitude as B and parallel to A is. Here you have to find the unit vector of A and B individually. Magnitude of B, that is root of 7 square plus 24 square, that is root of 625 or 25. The resultant vector would be of magnitude 25, but at the same time you require it parallel to A. How can we get the direction of a given vector? It is represented by the unit vector only. So you get the unit vector of vector A, multiply it with magnitude of vector B, that is 25, and you will get the resultant vector as 15 I cap plus 20 j cap. Option D is the correct answer. If A is 2 I cap plus 4 j cap minus 5 k cap, the direction cosines are cos alpha, cos beta, and cos gamma is being asked. Direction cosines are calculated in the 3 axis directions by dividing the component in that direction with the magnitude of the vector. That means cos alpha would be 2 upon root of 2 square plus 4 square plus 5 square, that is root of 45. So what would be the correct answer? Option A. Vector A makes equal angles with x, y, and z axis. That means cos alpha, cos beta, and cos gamma would be same. Value of its components in terms of magnitude of A will be cos square alpha plus cos square beta plus cos square gamma is equal to 1, as the three are equal. So 3 cos square alpha is equal to 1, or cos alpha is 1 by root 3. So ax, ay, and az would be equal to a by root 3, a by root 3, and a by root 3. Two vectors a and b are given and the angle between them is to be calculated. Other than those two formulas, if you have studied cosine formula in mathematics, that can also be used over here. Just mention the name and do it. Now, if a and b are two vectors, the angle between them will be, either use dot product or use cross product or use the cosine formula. D is the correct answer. If two vectors 2i plus 3j minus k and minus 4i minus 6j minus lambda k are parallel to each other, then the value of lambda is, if they are parallel to each other, 2 into minus 2 is minus 4, 3 into minus 6 is j, minus k into minus 6. If they are parallel, then the ratio of A1 and A2, B1 and B2, C1 and C2 would always remain the same. That is 2 by minus 4, 3 by minus 6, and minus k by minus lambda. So option C is the, lambda is 2. Option B is the correct answer. A body acted upon by a force of 50 Newton is displaced through a distance 10 meter in a direction making an angle of 60 degree with the force work done. We have discussed that work done is dot product of force and displacement. Force is 50, displacement is 10, angle is 60. So Fs cos theta, 50 into 10 into cos 60 is half. So 50 into 5, 250 joule is the required answer. A particle moves from position 3i plus 2j minus 6k to 14i plus 13j plus 9k due to a uniform force of 5i plus j plus 3k Newton. If the displacement in meters, then what would be the work done? Force is given. Displacement vector is not given to you. What shall we do? We will subtract the two vectors, position vectors, to get the displacement vector, that is 11i cap plus 11j cap plus 15k cap, and get the dot product of these two to get your answer as 100 joule. A force F given by minus k yi cap plus xj cap, where k is a positive constant x on a particle moving in the xy plane. Starting from the origin, the particle is taken around the positive x-axis to the point a comma 0 and then parallel to the y-axis to a point a. The total work done by the forces F on the particle is better to break components. For motion from 0, 0 to a0, the force comes to be minus k a j cap. The displacement vector can be calculated very easily. It is a minus 0 and 0 minus 0. So we get work in the first case to be 0. If the work is now to be calculated from A0 to A0 to A, the displacement vector when multiplied by force in these cases, first one the work done is calculated as 0 because displacement was AI and the force calculations were done. In the second case, work done comes to be minus Ka square. If we sum the two, we get the net work done as minus Ka square. If A and B is equal to C, cross product of A and B, if it is equal to C, then which of the following statements is wrong? I told you that cross product, the resultant of cross product of two vectors is mutually perpendicular to the given vectors. So in this A cross B is equal to C, then C is perpendicular to A, C is perpendicular to B. Again, if we go through the options, C is perpendicular to A, C is perpendicular to B. Which one is wrong? A is perpendicular to C, it is correct. B is perpendicular to C, it is correct. C is perpendicular to A plus B. C is perpendicular to A plus B. Vector A plus B would exist or lie in the plane containing the vectors A and B only. So if C is perpendicular to A as well as B, it has to be perpendicular to A plus B. But C is not perpendicular to the cross product of A and B. C is parallel to, you can say, if ever needed. Answer is D in this case. Two trains, a bit of relative velocity along with same straight rails, moving with constant speed 60 km per hour and 30 km per hour respectively towards each other. It is 60 km per hour and 30 km per hour. If at same time t is equal to 0, the distance between them is 90 km. In what time will they collide? Relative velocity, as they are moving in opposite directions towards each other, the velocities would be added and the relative velocity would be 90 km per hour. Distance between the trains, relative speed is 90, relative distance now it would be called, relative distance is also 90. Time is distance upon speed. 90 by 90, that is 1 hour. Your correct answer is option A. Two trains along the same. Okay, this is done for the day. Now, a bit of suggestion. Until unless you don't carry out or you don't understand the concepts of vectors, until unless you don't think that you are very much friendly or you are not very much acquainted with the basics of vectors, I would not suggest you to go with different chapters of physics. So the first and foremost thing is to get a good hand on this topic vectors. Similarly, in our country, the situation is regularly getting worse. It has been declared today by the central government that no schools or colleges would be opened by 31st of December. None of the state governments now has the permission to open school or college till 31st of December. This shows the severeness of the issue. So please enlighten a candle of social distance and use of mask around you. You can do it. You are the young generation. You also use mask and save the society. So that's all from my side. Asad sir.
Yes, sir. थैंक यू सो मच हितेन सर एंड डेफिनेटली आपने बहुत अच्छे तरह से वेक्टर्स के बारे में बताया है और बच्चों को जैसा पता है कि निश्चित रूप से अगर वेक्टर्स के बारे में जानकारी नहीं होगी दे विल नॉट बी एबल टू डन ऑल द चैप्टर्स इन अ वेरी गुड मैनर और डेफिनेटली स्कूल्स के अभी ओपन होने का कोई चांस नहीं लग रहा है 31 ऑफ दिसंबर के बाद ही गवर्नमेंट के आर्डर्स आ गए सो दैट विल बी गुड कि स्टूडेंट्स आपके साथ जुड़े रहें और आपसे फिजिक्स के रिलेटेड जो भी टिप्स हैं लेते रहें और अपनी पढ़ाई घर पे करते रहें सोशल डिस्टेंसिंग का पालन करें जो गवर्नमेंट की गाइडलाइंस है उसको फॉलो करें आई हैव शेयर्ड फीडबैक फॉर्म इन लाइव चैट बॉक्स काइंडली फिल द स्टूडेंट्स आर रिक्वेस्टेड काइंडली फिल द फीडबैक फॉर्म एंड रिटेन सर आई वुड लाइक टू थैंक ऑन बिहाफ ऑफ वन मार्क सॉल्यूशन एज वेल एज ऑन बिहाफ ऑफ ऑल द व्यूअर्स थैंक यू सो much for being with us and hope in future we will again conduct different webinars for the different chapters with you. Thank
Sure
you so
sir.
much. Thank you one and all.
Thank you sir. Thank you.